Wasabi, you guys. Welcome to Integration B Training for Advanced. This is the third part for Queen's Rule. So let's go ahead and get started with our first integral. This is a very common integral that you will see in competitive integration Bs. In fact, I would rather have you memorize this integral. This integral is equal to negative pi over 2 ln of 2. Okay, I would rather just have you guys memorize this integral because the process of solving it is very disgusting. So let me show you how it works, so that to help you memorize this integral. So when we do Queen's Rule, right? When we do Queen's Rule, we get ln of cosine of x. Now, because of that, this is equal to, when we add this up together, you get ln of sine of x cosine of x. In other words, we get sine 2x over 2. That's what that is, okay? Again, I have that half because I just skipped the step of just adding both of these integrals, right? 2y, but I itself, it's just divided by 2. That's all you do it, okay? And of course, sine of x times cosine of x is equal to sine 2x over 2, okay? So now this is where the ln of 2 comes from, right? Here, now we have a half, 0 pi over 2. We have ln of sine 2x. Okay. And then we have minus ln of 2 dx. So here's the hardest part, right? This is the most hardest part here. I even get stuck on this part as well because it's really annoying. It's a very annoying integral. It is. I'm not joking when I say that. It's a super annoying integral. If we let u equal to x, right, we get 1/4 from 0 to pi ln of sine over x. We can just write it like that. And then this is minus pi over 4 ln of 2. If you let u equal pi over 2 minus x, now you're probably thinking, Silver, what the hell are you doing? Why are we doing this when our bounds is from 0 to pi? So what I'm doing is I am creating a symmetry. So what I'm doing is I'm going to make this pi over 2 and make this negative pi over 2. Okay, so now what I have is 1/4 negative pi over 2, pi over 2, okay, and then ln of cosine of x dx. What we have here is this is equal to 1/2 0 pi over 2 of ln of cosine of x dx, right? Wait a minute, but look, that's literally what we have here. Except that, oh, well, we have this equal to this minus pi over 4 ln of 2. Okay, so now let's call this one I. So we have I equal to a half of I, right? This is a half of I, minus pi over 4 ln of 2. Then what we do is we solve for I, right? We solve for I, we get a half of I of negative pi over 4 ln of 2. And so the integral is equal to negative pi over 2 ln of 2. Okay? And that's where this comes from, right? That's where this answer comes from, right? The ln of 2 already, honestly, as soon as you get to here, well, let me color this green. as soon as you get to here, this should already help you memorize, oh, okay, the answer to the integral of ln of sine of x from 0 to pi over 2 is equal to negative pi over 2 ln of 2 because of this, right? You might say pi over 4, but remember that this is Queen's rule that you're dealing with. So, I'm sorry. I probably should not say that. You'll accidentally divide another 2. But pretty much that's where this ln of 2 comes from. So again, the whole process is nasty. It's confusing. So especially when you integrate fast, you can easily make a mistake here. So for sure, just want to let you know. Let me clean this mess up and rewrite it again for you. The integral from 0 to pi over 2 of ln of sine of x. This integral, it comes up so many times. You might as well just memorize the answer. Negative pi over 2 ln of 2. Okay? Memorize that, and you'll thank me so much. It is a lifesaver. Trust me. You do not want to speed integrate this. You can easily mess up. So, yeah, the answer is negative pi over 2 ln of 2. Okay? And if you can't remember that, just remember this part here. Okay? Huh. What do we do here? Ah, okay. I see it now. We're going to do integration by parts. Just trust me. Just trust me. Integration by parts. This is cotangent of x. Right? And integrate this, what is it? ln of sine of x. So what we have is this is equal to x ln of sine of x from 0 to pi over 2 minus 0 to pi over 2 ln of sine of x dx. Ah, what did I say? This is a very reoccurring integral. Okay, so what do you remember what this answer is? Do you remember? It's very crucial. I was about to say cruel. It's very crucial that you memorize this integral here. So here, pi over 2, 0, plug in 0, take the limit, it's 0, so this whole thing equals 0. Here we have negative 0 pi over 2 ln sine of x dx, which means that this whole answer here is pi over 2 ln of 2, right? It's positive because we have the negative here, so the negative cancels out, that's why, right? If this wasn't negative, then this integral itself would be negative. But because we have that negative sign, this integral is positive pi over 2 ln of 2. Okay? Okay, I see a bunch of sines and cosines. And then I see 0 pi over 2. So, let's go ahead and abbreviate this. On my sine cosine. Then this, by Queen's rule, this is equal to cosine cube. And of course, when we add this together, we get sine cube plus cosine cube on my sine cosine. If you remember, we can factor these out, right? We can factor them out. Sine cosine, sine squared minus That's exactly what that is. So what we have is sine plus cosine dx. So now we have a half. We just go ahead and go straight into integration here. Sine of x cosine x from 0 to pi over 2. So this becomes, so we plug in pi over 2, we get 1 minus 0. And then, let me write it like this. 1 minus, then plug in 0, we get 0, plug in 0 here, but we get 1. So that gives us -1 plus 1. Oh wow, would you look at that. This whole integral is equal to 1. Wow. What do we do here? This is very, very awkward looking integral. So don't panic. Don't panic. Right? We have some iterating trig functions. Well, not iterating, but some composite trig functions here. It just looks awkward, right? But what happens if we just use Queen's rule? If we just use Queen's rule, then we get sine square cosine of x plus cosine square sine of x. So what happens is when we add two of these integrals, then what we get is we get sine square plus cosine square. That's 1, right? We have sine square of sine of x plus cosine square of sine of x. We get 1 plus cosine square sine square, another 1. So what we have, this is 2, this is pi. So our answer, I hope I did that correctly. I hope so. 2 pi over 2 should be pi. Yeah, so this integral, the whole integral here, should equal pi over 2. So what do we do here? How do we solve this integral? You might be tempted to just, just kind of distribute, but let's take a step back. Maybe there's a reason why this is here, right? We color this in yellow. Let u equal pi over 2 minus x. Then what we have is negative pi over 2, pi over 2. Then we have u, and we have cotangent of u, du. This is an even function. 0 pi over 2 times 2. I don't know why I write it like that. I'll put it here. 2. This is literally this. Do you remember? Do you remember how to do this integral? Right, this is take the integration by parts. You end up getting -2 of this integral here, right? Do you remember this integral? Remember this integral, this nasty integral, right? This is equal to -2. This is negative pi over 2 ln of 2, right? Because 0 to pi over 2. And so now our answer is pi ln of 2. All right, now we're going to go JEE Main style. So, how do we solve this integral? What is this integral, in fact? Right? If we go ahead and just simplify it, right? So do some trig manipulation. Let's do cosine bottom and top. Or in fact, I think it's not. It's better to just abbreviate it. So if we abbreviate it, cosine. Okay. And then of course by Queen's rule, if we apply Queen's rule, we get sine, and then this again. Okay. So now what do we do here? What do we do here? If we add it together, right? If we add this together, we're just gonna get this. But how is this going to help? How is this going to help? So, you see this 2 right here? Go ahead and just kind of distribute that at the bottom. Trust me, just distribute it at the bottom. Right. Then we get 2 plus This should kind of give you a light bulb here. Do you remember our intermediate training where whenever we see something like one plus, and then we have 1 plus sine of 2x? What does this look like? Aha. So, it looks like we will be using the 1 plus sine 2x trick here. Now, be very careful. Our derivative, so we need our du to be sine and cosine. So what does our u need to be? If we integrate this, we get sine minus cosine. So we need sine of x minus cosine of x. Right. That's what we need. We need sine minus cosine. So this needs to be negative. We need something like sine minus cosine square, but this needs to be negative. Right. And this would just become 1 minus sine 2x. So because we added a negative 1, we need a plus 1. So this would give us 3. Right. And now we have s plus c plus s, technically. Just to easily see our derivative. And now... I'm so stupid. We technically already plug in the bounds. So what we have is 3 minus u square du. And oh my god, that is disgusting. I really wish it was sine plus cosine. But damn, that's horrid. Well, you know me. I'm gonna go root 3. Oops, that's a bad 3. Inverse tanh of u root 3 from -1 to 1. I mean, this is technically even, so we can go like 0, 2. So this is technically even. This is technically even. Inverse tanh of 0. That is 0. So our answer is 2 root 3 inverse tanh of 1 over root 3. I think this would be my answer. This would be my answer. And to double check, this could be rewritten as 1 minus 1 over root 3, 1 plus 1 over root 3. Oh, I'm sorry. With a half. There's a half here. Don't forget that there was a half. So then this would be like ln square root of 3 plus 1 square root of 3 minus 1. It'll be something like this. I think this is the JEE Main answer. As a lazy person like me, I'll just leave it as inverse tanh. So here we're just going to go ahead and dive into Queen's rule. Right. Let's see, pi over 2. Let's put a half there. Actually, I'll color it in red to let you know that I've already added 2 integrals. So let's go ahead. We already know what this looks like. Cosine, sine, and we have this to the power of 5, and now this is equal 0 to the power of 2. This is now c and s to the power of 4. Now we can go ahead and do power of 2. So now what we can do is we could do secant square, right? This is very hard to see, but secant square here, and what happens is what you're doing is you're having secant square, that's literally secant of x times cosine of x plus sine of x. Right, this is very hard to see. It's very hard to see. Right, secant square is equal, inside the fourth power is secant x, square root of secant x. Okay, so that's how we're able to distribute this, and now this gives us from 0 to pi over 2. We have 1 plus square root of tangent x to the power of 4. This gives us, let's see, if we do u substitution, we get 1 plus square root of u to the power of 4. W equals square root of u. We get a half, 0 to infinity. 1 plus w to the power of 4. We get 2w dw. What does this look like to you? This is a beta function. This is a beta function. You cannot forget that. This is a beta function. That's so important. So it's a beta function. Okay. So this is equal to, let's see. If you remember, let me write this in, right, b of m. Let's see if we remember. Do you remember the formula? Right, it was m plus n of x m minus 1. Right, so here we have m minus 1 equal to 1. So m should equal to 2. Okay. And then here, m plus n, we know that this is 2, so n is equal to 2. Alright. So we have beta 2 and 2, which means that we have gamma 2, gamma 2, gamma of 2 plus 2. The answer for our integral is 1 over 6. Before I continue with the next integral, I do want to show you an alternative solution. So, to tell you the truth, this function is actually elementary. It is an elementary function. You can solve this without Queen's rule, right? It's just very hard to see. And the trick is, what you're going to do is you're going to do secant x to the power of 5, square root of secant x to the power of 5. And you're going to do that top and bottom. And what this will give you is actually from 0 to pi over 2, this cancels out, and you'll be left with secant square of x dx. And then here, inside power of 5, you get square root of tangent x plus 1. Okay? And when we do that, we get from 0 to infinity, we get du square root of u plus 1 to the power of 5. Now you're probably thinking, Silver, this looks nasty. Trust me, it's not as bad as you think it is. If you just do force u sub, just perform force u sub, right? Let w equal square root of u plus 1. then you have w minus 1 squared equal u. Then we just have 2 times w minus 1 dw equal du. And so what you'll be left off is, don't forget the bounds. Don't forget the bounds. 1 infinity, it's not 0 to infinity. A lot of people would make that mistake. And then 2 times w minus 1 dw, and then w to the power of 5. And look, it's just, this is just straight up power rule. So now we have 2, this is 1 over w4, so we get 3w cubed. I'm sorry, that should be negative. So I'll put it right here. While this negative becomes a positive, this is 1 over w5 for w4 onto infinity. Plug in infinity, everything's 0, right? So we get negative 2 of plug in 1, 1/4 minus 1/3. Right, now this gives us 2, 1/3 minus 1/4, 3 minus 4, 4 minus 3 technically, because we just cancel out the negative, and we end up with 1/6. Okay? That is the elementary solution. In fact, I would say this is the fastest method, in my opinion. Okay? Alright, so we have this integral here. Let's see, if we try Queen's rule, we will get sine cosine square, and then cosine sine square dx. So if we add it together to y from 0 pi over 2, we have sine of sine square cosine of cosine square plus, let me rewrite this as cosine sine square and then sine of cosine square. And so now what we have, this is a trig identity, law of additional angles, something like that. So this is equal to sine of sine square plus cosine square, which is equal to sine of 1. So in general, our answer would be pi over 4 sine of 1. And this is our answer. Okay? And that is our last integral for this section. So a lot of advanced techniques with Queen's rule. It's a lot to take in. So I highly recommend that you rewatch this and try it yourself so that you get more comfortable with these advanced manipulation with Queen's rule. Okay? One more section to go. We have one more section to go. It's even more advanced with Queen's rule. So stay tuned for that. So yeah, thank you so much for watching. And I'll see you guys in the next video. See ya.